Welcome to our second chemistry lesson on video. We're going to be starting on page 187 of your textbook, chapter 11.5. Today's lesson will be about copper and some other precious metals. So, copper can be found sometimes as a free element in nature. Anymore, it's a lot rarer to find that, but copper is right here in the transitional metals. It's at the top row. It's Cu is its chemical symbol. So anciently, they would find copper more often as just a lump of copper, but anymore it's usually found in an ore. So there's several different types of copper ore. The first one is called chalcopyrite. And it's made up of copper, iron, and sulfur. And the next type of copper ore is made up of cuprite, which is copper oxide, which is just copper like that. And the one that I'm most familiar with is called malachite, which is copper, carbon dioxide, or carbon and oxygen, sorry, and it's in the presence of some hydroxide. And malachite is something that has some green tones to it. You'll see it sometimes, green and blue tones that have those peacocky looking minerals out in nature quite often. If you see though, there's a really good chance that it has at least some copper in there, some of the metals that are in there. The process of purifying copper is they heat it, and it's a flotation device where they float off the stuff that they don't want and leave the copper. And one of the reasons why flotation is really important is because the ore itself does not have a lot of copper in it. If you think of Bingham Copper or Rio Tinto or whatever you want to call it, Kennecott Copper over here in the state of Utah, that's one of the largest mines in the world, there's a fairly, even though it's worth mining the copper, as far as the volume, it's usually about 0.5 to 1% of the everything that's grabbed is actual copper. Everything else is, most of it's waste and everything, and so you have to do a lot of work to get it out of it. Chalcopyrite, they heat it up in the presence of oxygen, and it helps to separate out the iron mixes with that oxygen, and they're able to float that off so that they can get down to the pure copper. At that point, the copper still has a lot of impurities in it. It has silver, some gold, zinc. It also has arsenic in it at that point. And so then they take what, it looks kind of like copper at this point, but it has all these other impurities in it. And so then they put it in an electrolysis process here again where they take high current and run it over it, and it helps to separate out to where they can get the copper really pure. And it's really important that it be as pure as possible for a lot of its uses, because even as little as 0.1% arsenic in the copper will make it so that it loses 30% of its ability to conduct electricity or heat. So especially that arsenic's got to get out of there. One thing that we use copper a lot in our houses and things to conduct electricity. Some people use it on their pans. You'll sometimes see copper pans and things, and that's because it conducts heat really well. The only element that conducts heat or electricity necessarily better than copper is silver. And you can probably guess why we don't have silver wires running through our house and everything, because even though copper is expensive, silver is way more expensive. So silver is used for other things usually. When you put copper on things, if you've been up to the state capitol building, the dome on the top is covered in copper. Several years ago, they recoated it and it was bright coppery looking for a year or two, and then it starts to oxidize and creates this copper oxides. And those copper oxides are pretty tough. It's one of the cool characteristics of copper is that the oxide is tough and stays bonded really well with the copper that's underneath. If you think of an iron oxide, that's rust. And one of the reasons why rust is so bad on a car is that as it rusts, it flakes and it breaks off and then exposes raw metal under it, which then rusts and then flakes. And it kind of creates this cancerous action on the steel, but copper doesn't do that. Copper gets this copper oxide that's really a tough surface, and it has that bluish, greenish color, and that's one of the reasons why it works really well. And you can also think of like the Statue of Liberty is made out of, the covering is copper, and they just barely did some renovations to work on it, but it was, really, really old, the original coating, because it lasts a really long time, better than most other things for that reason. Some people will even do copper plating on their own roofs, even though it would be quite expensive to do it because it lasts so well. Let's talk about a few of the different alloys that are mixed with copper to give it different characteristics. So, brass. Brass is a yellowy, bright, shiny metal. If any of you like to go shooting, the cases are made out of brass. A funny little note in history about that was that at the end of World War II, Truman was worried that the Japanese and that might attack our brass mines, and so he wanted extra protection, even though there isn't such a thing as a brass mine. But anyway, brass is made up of copper and zinc, and approximately 35% zinc is mixed, so the total amount, 35% of it's zinc, and it gives it that brass yellow color. It's actually a harder material than pure copper, and it's really malleable and able to be forced into shapes really well, and it has a lot of good attributes for that kind of stuff. Historically, some things like door handles and things would be made out of brass and that, because it was pretty resilient and had a pretty hard, long-wearing metal. Easy to work with too, a lot easier to form in that than things like steel. Another alloy is bronze, and bronze is copper and tin, and most bronze has either somewhere between 5 and 10% tin by mass, and it's also good for a lot of things. You've probably seen bronze statues. It has a really strong tensile strength where a very small wire can be pretty strong and not want to bend. It's not as hard as steel, and so anciently they had the Bronze Age where where empires would make their swords and spears out of bronze, but when iron started to become available, it was a lot harder, so that kind of stopped that. But even to this day, bronze is used a lot in places like in oceans, where a lot of the propellers are made out of bronze because it resists corrosion, and it for propellers and different fittings and valves. A lot of valves that are made out of some kind of bronze and that, because it doesn't corrode quite the same way and is able to handle things. Another interesting historical thing about ancient ships that were made with sails is they would plate the bottoms, like the USS Constitution. The bottom part that would sit under the water had copper plating that was nailed to it, because it would reduce the amount of barnacles and that would build up on it, so the ship would remain fast in the water, even though it's a fairly expensive process to do that, obviously. So that kind of will be the end of our discussion of copper for the moment. Let's move on to some other precious metals. So gold and silver. So right here, this was copper, and this is silver just right under it. Its symbol is AG, and right under that is gold, and its symbol is AU. And you can look at those in the back of your book, because I don't know on the video whether those show up really well, but in the back of your book you have your periodic table that you can look at. Now, a couple other really important precious metals are known as, well, there's platinum, and then there's the platinum group, as it's called. So platinum is right next to gold, just to the left of it, and then there's iridium, osmium, ruthenium, palladium, and rhodium. These kind of elements right here are called the platinum group, and they're all very expensive in modern times, and they have certain values and uses that we'll go over. So one reason for the value of gold has been its rarity, but also its brilliance, the fact that it doesn't oxidize very easily, so it stays pretty even when it's been exposed to grime and dirt and water and things like that. It stays pretty. It's easy to pound it and to shape it, so anciently it was easy to be put into coins. But its rarity is really interesting. There was a note in the book that said that they think that all the gold that has ever been mined, all put together on the earth, would fit into a 60-foot by 60-foot by 60-foot cube. All the gold that's ever been mined. So when you think of all the little rings and everything else, all the gold would fit in a 60-foot cube. Now, another thing that's interesting about gold is it's almost always found as a free element in nature. And a lot of the times the way it's found is in nugget forms in rivers. And we've talked a little bit about the process of panning and how you can pan for gold, and that it's really dense, so it will stay in the bottom of the pan when lighter weight things will be washed off. As far as gold ores go, if somebody's going to mine for gold, then it's usually about 5 to 10 grams of gold per ton. So you've got 2,000 pounds of gold, and in that 2,000 pounds of ore, 2,000 pounds of ore, and you're looking for just 5 to 10 grams of gold, and at that level it's worth mining. Silver is a lot more common than gold, even though it's not found naturally by itself very often. It sometimes can be found as little small pieces, but it's a lot rarer. And it's alloyed with a lot of other metals. Platinum can be found as a pure metal, but it's almost always bonded with some kind of sulfur, as some kind of sulfide compound. On the earth right now, most of gold mining is done in South Africa in really, really deep mines. They have some mines in South Africa that are 13,000 feet deep into the earth. That's staggering. I mean, when you consider that we here live at about 5,000 feet, and the top of Mount Nebo is just barely less than 12,000 feet above sea level, and these mines are deeper than going from the top of Nebo down to us, and then about that much farther down into the ground even farther. That's just amazing. And they're really, really hot, and I've heard that they're really, really uncomfortable for the people that work down in there. They have to pump cooler air down in there, or people would just die from heat exhaustion. Another way that we get a lot of gold and silver and stuff like that, though, is also through the purification of copper that I already talked about. In fact, at Kennecott, copper, even though it's called a copper mine, they get enough gold and silver and these other precious metals that these other metals pay for all the trucks to run, buying all their new equipment, doing everything that they do, and the copper is just pretty much pure profit. If we look at page 188 and 189, there's some photographs there that show some uses of the elements, of some of these elements. So, like on figure 1114, you see some uses for gold. There's the gold nuggets, but then you also see the computer chips, the pins are gold. And one of the reasons why they use gold pins on the computer chips is because it doesn't oxidize, and so years down the road it doesn't lose its conductivity, where if it was silver it would oxidize, and the silver oxidation doesn't conduct as well. And so that's one use for gold. Another thing over here on the side is silver, and you can see some of the gold or the silver bars, and there's some pictures there of platinum and things like that. Now silver, another interesting thing about silver is the sterling silver. Sterling silver has about 7.5% is copper, which makes it a little bit harder so that it's less soft and doesn't scratch as easy. But when you polish it, the silver covers all the surface, and things like silverware and pretty vases and things that are called sterling silver are made out of those. And over time it will tarnish and get that rainbowy black color, and that's from the silver oxides and some of the other tarnishing things like some of the sulfides that are in the air will create some of those tarnishing colors. One thing that's interesting to note about silver too is that when it's polished, it's the shiniest element on Earth. Nothing's shinier. So in space, they will silver coat mirrors and stuff to give it that super shiny. The best mirrors in that are silver coated. Another thing that's interesting about gold, we'll talk a little bit about gold and how you rate its purity. So gold is rated by its purity in carats, and that's K-A-R-A-T. Carat. So pure gold is 24 karat gold. So pure is 24 karat, means every bit of it is pure gold. Now, it's so soft that very, very few things are ever made out of pure gold. Even most coins, unless they're specialty coins, weren't pure gold because it's so soft it deforms. You can just press on it and dent it and everything. Most coins are made out of 22 karat gold. So most coins are going to be 22 karat gold. Most jewelry is made out of 14 karat gold. Keep messing up, sorry about that. 14 karat gold. Now, some people would say, well, that's about, what this is that means that 10 parts are something else. So with 14 karat gold, 10 parts of it are some other metal. White gold is usually made up with about 10 karat gold or that's some other thing, like it's made up of nickel and things like that to help to make it white. That's what white gold is usually made up of. Now, let's talk a little bit about platinum group and some of its uses. So currently the number one use for platinum, even though it's a super expensive metal, is in catalytic converters and things that are used to clean up the air and things like that. It's a catalyst that helps to gets hot, and when it gets hot, it helps other things to burn cleaner. And so almost all modern automobiles that I know of have a catalytic converter in the exhaust system that gets really, really, really super hot, and the platinum that's in there ends up eating up or causing these chemicals to burn more cleanly so that they don't create as much problems for the environment. Another use for platinum is on electrical devices as well, because it is a good conductor and doesn't corrode very easy. Osmium, which is right here, is another one of these rare metals, and it's the densest naturally occurring metal on Earth. It's even denser than gold. So if you're out panning, there's a chance you could get one of these other metals right here, and they're all very similar. And the reality of it is if you were to get them, you wouldn't be sad because they're all worth a lot of money. But osmium is really dense. It's about twice as dense as lead is. Now, what I want you to do is we've finished the next couple of sections in chapter 11. And so section review 11.6, at the bottom of the page of 189 is the section review. There's 6 questions there. So I need you to answer those 6 questions, and you will want to turn them in to Sister Sandra at the school, however that works, and then I will correct them and give you credit for that. And that's one of the ways we're going to keep track of how well you're doing on keeping up with my lessons and stuff. So we'll see you at the next lesson.